effective rate, but I want to get the annual percentage rate, right? So it's the inverse of the other function. So this is how I would do it. Actually, two ways to do it. I could say that one, what is the EAR again? It's 1587, so 1.1587, I could say that equals 1 plus APR over, it's quarterly, right? Over 4 to the 4. I could say that, right? And then I solve for APR. Can I say that?
Yes. Sure.
I mean, that will be valid if I ask you to show your work. And then once you write this, then you could go ahead and use that function, the icon function, to produce your APR, right? Mm-hmm. See this?
Yes.
Now, if you use that function, what is the FA?
So 15.7.
187. That's your FA, right?
Right.
And now, what is the C sub Y?
4.
4. And then I compute num, right?
Right.
And then what do you got?
15.
You get exactly 15?
No, 15 or 3 something.
And that's probably due to rounding again, you know?
Mm-hmm.
So what is the best answer?
15.
15, right?
Mm-hmm.
Yes.
Is that I sub y? What's the C sub y?
Do you have it in your calculator?
I'm
Did you
s-
use the icon function?
I'm sure I have. Sorry.
But why don't you go to the icon function? Second, 2.
Oh.
Okay, and then num, so here you have to go down, right? And then you see FA. Type
15.87. Enter.
Enter, and down arrow.
I see.
See now?
Yes. Thank
4.
you.
Down arrow, compute.
Thank you.
See?
Yes.
15.00 something, right? It's actually 004.
1044. Sorry.
Clearly, the answer with 2 decimal points for the percentage is 15%, right?
There are 2 ways of solving this? Is that the 2 ways?
Well, that's one way.
Yeah.
Now the other way, actually there are 3 ways when you think about it, because of your way.
Okay.
No. So, but let's do the second one. The second way is to say that the APR is going to be 1.1587 raised to the power 1/4, right? Minus 1, and then the whole thing times what? 4. Now, of course, if you use this way, maybe you want to use the numerical solution, right? Enter everything as into your calculator as it appears, right? Guess what? If you do that, you get the same answer. 0.15004, right? Something like that. If you want, you can try. That's the second one.
You only want us. Oh, you want us to go all the way out to 0.0044, all 4 decimals?
At least, if because it is a percentage, if you stop here, it's fine.
Okay.
Or like here, right? Because of 4 decimal points, right?
Right.
And here. See that?
Yep.
Now, you know what the third way is? The third way is pretty much still, I still want you to enter this, right? For the third way, I will still use this, that 1.1587 is 1 plus APR over 4 to the 4, except that now I'm going to use the PVFV function. Right? I'm going to say this, that 4 is going to be my N, right? 0 is my PMT. -1, because of the 1 that I have here, right? Is my PV. Does that make sense? You know what my future value is? It's that 1 point 1.1587 is my future value. You see this? You know what I solve? I solve for the rate. Why? Because I'm looking for this rate here, right? So I say compute I. Do you see what I'm doing here?
Yeah.
So basically, it's as if I had a 1 here. So that's my PV, that's my FV, that's my N, but then I'm looking for the rate. But it's going to be a rate per period, right?
Yeah.
So what do you get? I think you're going to get something around
I got 3.7.
75, right? Very good. But that's the rate per period, and then you multiply by 4. Right? So it gives you 3.75, but that's the rate per quarter, right? Because it is your APR over 4. So therefore, what is the APR? You need to multiply by 4. So this number is my APR over what? Over 4. Because after all, it's solving for this, APR over 4. My APR over 4 is 3.75%, so therefore, what is my APR? 15 what? That's another way of doing it. But sometimes in class, I don't like to give too many ways, you know?
Nope.
You know what I mean?
Yeah.
I knew that there was this way, but I was, yeah, they already have 2 ways, you know? So which way do you really prefer? That's up to you. But you still need to show me what are those equations? Either this form or that form, and then how you get the answer, I don't care. Next. 41 can't do because it is a real value problem. 42. I need a reader.
The payment made each period on an amortized loan is constant, and it consists of some interest and some principal. The later we are in the loan's life, the larger the principal portion of the payment.
Yeah, so basically here we're assuming that we have the constant total payment amortization, right?
Yes.
Is that true?
Yes.
Yeah, it is
Yeah.
true. Yeah, the later we are in the loan's life, the larger the principal portion of the payment. Why? Because the interest payment is declining. So therefore, more is allocated towards the principal. Does that make sense? 43, I need a reader.
You're evaluating income generating property. Net rent is received at the beginning of each year. The first year's rent is expected to be $8,500, and rent is expected to increase 7% each year. What's the present value of estimated income stream over the first 5 years if the discount rate is 12%?
What type of a problem is this one?
Present value goes on into
Growing
due.
The present value of a growing annuity
Due.
due. Why is it due?
It's a beginning,
Because,
that's a beginning.
exactly, net rent is received at the beginning of what? Each year. Right, so you knew right away that it was about a growing annuity, especially because of cash flow growing at a certain rate. You see this? Right? Do you want me to do it? I think we did this one in class too.
Yeah, it seems familiar.
Let's do 44. You need to accumulate $10,000. To do so, you plan to make deposits of $1,250 per year, with the first payment being made a year from today, in a bank account that pays 12% annual interest. Your last deposit will be less than $1,250 if less is needed to round up to $10,000. How many years will it take you to reach your $10,000 goal? How large will the last deposit be?
Okay. That's also a lengthy problem, right? It has too many questions, you know? But anyway, let's do the first part. The first part says, the first question says, how many years will it take you to reach your 10,000 goal? That's definitely a future value question, right?
Yep.
Okay. And then we know that you need to accumulate $10,000, and then you're making deposits of $12.50 at a certain rate. What is the rate here? 12%. So part one, it's a number of years, so 10,000 will equal the future value of an annuity, right? So here I'm looking for N, so that 10,000 will equal that future value, 1250 times 1.09, is that 9%?
No, 1, 2.
12%, sorry, 12%, and then raised to the power N, my N is the unknown here, right? Minus 1 over 0.12.
12.
And then you go to your calculator to solve for N. But you have 12 for I. You have negative 1250 for PMT, do you agree?
Yes.
And then you have 0 for PV. And then you have 10,000 for FV. And then you compute what?
N.
N. So what do you get?
5.5. This is not a due question because it says the beginning of the year made by a year from today. The first payment
Wait,
being
it
made
says
a year
it's
from
ordinary because it says with the first payment being made a year from today.
That means it's ordinary.
It's ordinary, right?
I thought that.
No, it's say, well, read it again.
Okay.
It says the first payment being made a year from what?
A year
From today. So that's as if it was at the end of the period. Because for it to be due, it has to be made what? Today. It's not a year from today. It's gotta be today. Do you see the difference?
That means the question says as if it's the end of the period.
That's
End
right,
of the
it's the
period.
same thing. The end of the period, two ways of saying that. Either I say, well, at the end of the period, or the first one is made next year, which is pretty much what this one says. The first payment being made a year from what? Today, which is next year. Do you get it?
Yeah.
So if you go to the timeline, it's really a period one, which is the end of year, the first year, right? Or in year one. And then you solve, what do you get?
5.9380.
So then we get, so here I said, well, that implies that my N is 5.94,
9.4, I don't know, maybe
which is about 6, right? 6 years. But we know that your last payment would not really be $12.50. Do you agree? They all agree, say yes or no?
Yes.
Why? Because it does not really take quite 6 years. I mean, it doesn't really take 6 years to really,
Right.
because it takes
9.
5.94 years. So
Uh-huh.
that means that in the 6th year, your payment will have to be lower.
That's good.
Does that make sense? And now that's the next
Yes.
question.
Right.
What will be that last what?
Payment.
Payment. Actually, for that part, there are really two ways to do it.
You computed 11 years total and then,
Why would you want to do that? Why would you want to do
Oh,
so
sorry,
that?
sorry, not 11. How many years is that?
Can you just do it algebraically?
What?
the future value at 5 years.
Okay, that's one way to do it. That's one way to do it, right? 5 years, and then you're gonna have to compound it, right? One extra period. Does that make sense?
Right. True.
Did you just set up a ratio?
For cash flow.
If I set up what the ratio?
6 is to 5 point.
You don't really, no.
Cash
The
flow
approximate.
worksheet.
What is that?
The approximate, it'd be good as the rule of 72.
Well, but the problem here is the amount is not really doubled. And also it involves, the rule of 72 does not really involve any annuity,
Yes.
right? Does that make sense?
Yes.
No, I think you were, I'm just throwing that out there.
Okay,
for that.
okay.
Can you do a cash flow worksheet?
So anyway, so let's do it one way. One way, the first way is to assume that there are 6 periods. Right? Let's assume 6. But we know that the last one, it will have to be less than 1200. But let's assume 6. and then we'll do the other one, right? Assume 6 years. So what is the future value? Well, it would be 1250 times 1/12, right, to the 6 minus 1 over 0.12. You all agree? Why don't you compute this?
That's $10,143.
$10,143 point,
No,
nothing,
sorry, 0.98.
98, or 999.
99.
You know what that means? That means if we consider 6 periods of 1250, then there will be an overpayment. Do you agree?
Right, so you just,
And then, so that, therefore, that's the overpayment for the last period, so you subtract that from the 1250. Right? So therefore, so there's an overpayment. So in the 6th period, there's the overpayment is really 143.99. So therefore, the last payment should be 1250 minus what? 143.99, so what is that?
It's less than
It's what?
1106.
1106.
1106.01, right?
Right.
So that's the answer. So we already knew that. We already knew that in year 6, your payment wouldn't have to be as high. Why? Because technically, it should really take 5.94 years.
Where did you grab that 143 from? Sorry.
When I did, again, that's why I said, let's assume 6 years. We
Right,
know
right.
that it should really be 5.94.
Yes, yes, yes.
But let's assume 6,
Yeah.
because it's gonna take 6 years.
Yeah.
Except that the last year, the payment would have to be lower,
A
right?
little bit less,
But let's
yeah.
assume 6. But if I assume 6, then now the future value is 143.99.
From 10.
And since the goal is 10,000, so that means that
Subtract.
there will be an overpayment of 143.99.
Got it. Thank you.
Sure. So you still want to do the other way? The other method? Well, the other, okay. But do you understand this method, right?
Yes.
Okay, good. So that's enough.
Okay.
I mean, there are always many ways to do things, but let's not complicate it. Okay.
Yeah.
If that one makes sense, let's stick with it.
So the number of the years, we say 5.93 or just say 6?
What?
They ask how.
Well, the previous question is what is